to hit the record button ahead of time so I won't forget it. So, how's life been, Ken?
Pretty good. Can't complain. Just finished volunteering this morning in Durham Habitat for Humanity. A little tired physically, but other than that, I'm great.
So you've been able to start back?
Yes, actually, start back last October. They limit the volunteer to 2 per house, and plus 2 staff, so it's just basically 4 persons working on a house.
Hi, Henrietta.
Hey, can you hear me now?
Yes, I can hear you.
Okay, I don't know if you can see me or not.
Can't see you now, but
There you go. Can you see me now?
Hey, yeah, I can see you now.
Okay, I didn't know. This is a new one. I've done a lot of them, but this is a new one. Okay. I'm gonna be able to stay probably until about maybe 4:45, and then I'm gonna have to.
All right. I'm just waiting for some others that are joining now.
Okay.
How you mute this? Hi, Chris.
Hey, Gary, how are you?
Good.
Can you hear me okay?
Yeah, you're coming in good.
Excellent, excellent.
Hey, Gary.
Hi, Beamer.
Long time no see. I still can't
know
see
it.
you. Who's that masked man?
and you're retiring.
I know.
Oh, this is just wonderful. It's so good to see everyone. This feels so good. I'm gonna sleep good. Let's see. We got John Muth. We got Jeremy Johnson. Mike Sullivan. Okay, so it's 4 o'clock. We'll get started, and I'm gonna just go down the list and I'm gonna just call your name out and just introduce yourself and to, who you're affiliated with, and I appreciate all of you attending. I know this was short notice, and I know you're busy, but Beamer, we'll start with you.
I'm Beamer Bevel, and I'm the department chair for the engineering and engineering technology here at Fayetteville Tech Community College.
And Beamer's retiring. What, May, Beamer? Is that right?
June the 1st.
Oh, June 1st. Okay. He has a great program down at Fayetteville Tech. I'm on the advisory committee, and I've been on it for 30-something years, and it's the best it's ever been, Beamer.
Thanks.
Chris?
Hi, I'm Chris Mayodu. I'm with Indian River State College in Florida and Laser Tech, the National Center for Laser and Fiber Optics Education.
Henrietta? Okay. We'll go. Henrietta, you got your mic muted, or we'll go to Jeremy Johnson. How about
I made it
John?
back, Gary.
Right there, Henrietta. Go ahead. Introduce yourself, Henrietta.
Henrietta Johnson. I'm at Jack Brett High School, and I was just cleaning off the 3D printer. Anyhow, and I'm at school. I teach integrated systems technology 1, 2, and 3, which is kind of 9th grade through 12th grade.
I've had several of her students come through the program, or a few of them, and she sends me outstanding talent. Jeremy Johnson?
Yeah, can you hear me, Gary?
Yes.
Okay, cool. Sorry, I had a little bit of trouble with my audio. So I'm Jeremy Johnson, graduated LEOT program at CCCC in 1996. That was with Steve Limpany. And right now I am the director of project management and engineering at Cree Lighting for OEM projects.
Okay. Thank you. John Muth?
Yeah. Hi, I'm John Muth. I'm at NC State. I'm a professor of electrical engineering. I do a variety of photonics and semiconductor work.
And Joseph Price? All right. Ken Lau?
Yes, I am Ken Lau, retired engineer. I live in Durham and been doing a lot of volunteering in horticulture. Enjoy myself.
Mike Sullivan?
Hi, I'm Mike Sullivan, and I work at Wasatch Photonics sometimes. I'm on the board of directors there. I'm an optical engineer, and I have another small company called SenseIR here in Chapel Hill that does hyperspectral imaging.
And MJ?
Hi, I'm MJ Swallow. I'm a faculty member in Creole, the College of Optics and Photonics. I teach a variety of optics courses, astronomy sometimes, and I do experiments with ultra-short pulse, high-power lasers.
Okay, so, and if you remember John
Levere here,
Levere,
teaching the electronics part of the laser and photonics program, working with Gary. Gary keeps me in line mostly, and I spend most of my time with the first-year students, and Gary spends most of the time with the second-year students. And we've got a group of first-year students here that are going to talk to you a little bit.
Bill Brown has joined. If you'd like to introduce yourself, Bill.
Sure. Bill Brown. I'm with Lumedica. We are in Durham, North Carolina, and we build optical coherence tomography imaging systems, and have had several graduates from CCCC work with us over the years.
Thank you. And Joseph Price, if you're connected now. Okay.
Tried to ping you. Maybe he doesn't have audio.
Yeah, maybe it doesn't have audio. I don't know. Okay, so we'll go on. I'm going to go through I'm going to share my screen and take you through the few slides that I have, and then we'll be connecting with the first year students and introduce each one and talk about some lab changes we're going to be making. And before I get started, does anyone have any questions or comments or anything like that? Does anyone? Okay. So here we go. This is share my screen. I'm not on that, I'm on Firefox. Okay. Share application. Allow. Okay. Hopefully everyone can see the screen.
Yep.
Okay. All right. So, of course, the purpose of the advisory committee mainly help us keep this improved and up to date. I depend on you big time for that. Of course, recruitment. And, I use all of your companies and names all the time, and it helps in recruiting and help with the curriculum content, which you've done in the past. Of course, career placement of students, field trips. Hopefully, we'll get back to that again, and coming in and talking with the students. And please, if you're ever in town and near, just stop by any time. If we're teaching, and you're welcome. Of course, scholarship funds or time, material, equipment donations, anything like that. Our status, we have 9 first-year students. You'll meet the majority of them today. There's a few that couldn't stay late. We have 7 second-year students that will be graduating in May. And of course, I was real glad that last fall they allowed me to have John and I, we were allowed to have our lectures and labs face to face. So the students were able to get the necessary training they needed in the labs and laboratories. We added an OCT and lab in the spring of 2021. Students really enjoyed it. We're purchasing a new CO2 laser engraver, and it's scheduled to come in, I don't know, 10 weeks or something like that. It's scheduled out, but it's already it's been approved and everything. And I'd just like to throw out that Laser Tech provided us photonics kits last March when they shut down the program, and we all had to go virtual. Those photonics kits were just lifesavers that we could get out to students and help with that. So thank you, Chris, for everything you did and Laser Tech did to make that happen. Of course, this is we strive to teach our students. John and I worked in industry, and we know the importance of strong work ethic. We drive that home with the students as much as possible. Making sure they arrive to work on time. We consider the classroom as a work environment. Problem-solving skills, importance of that. Attention to detail, teamwork, respecting others, and it's just amazing how when you emphasize these things, the students do them. And, so our mission, of course, is to produce skilled technicians that are well prepared for these fields they're going into, and we focus on recruiting good students, preparing them well, and emphasis is on placing into a career. Okay, and these are the areas that we is the major focus of our core classes. I'll let you look over that. If you have any questions.
Gary, are your slides being shared? Because I just see one slide.
I'm sorry?
I don't think you're in present. You've got the presentation, but I don't think you're moving through your slides. Like you're not in present mode.
Oh, well, I think I am. So maybe they're. So what slide are you seeing now?
The first one.
Oh, you're kidding.
There you go.
Yep.
I'll tell you what, let's just do it like this then. You see the second one now?
Yeah.
Yeah.
Okay. Well, that's counts and everything. That's what I read over. That's the third slide.
Yep.
Fourth one. That's the one I was on, where I was paused. And then this is where we had some companies do some virtual presentations to the class, organizations. Lawrence Livermore, a consulting company, TRC locally, and Sumitomo Electric local, and of course Megawatts in Hilton Head, Scott Hamlin. I think that was last week we did that. Placement, we had 2020, that's where everyone went. We had 8 graduates. And 2021, so far, these are the students that have been placed. Current openings, people that have reached out to us, those are the companies that have reached out with opportunities. If you have any other opportunities and your company's not listed there, you send me an email, I'd appreciate it. Our updated lab layout, we plan to have the argon lasers in this room, and we've acquired a 4,000 CO2 laser, and all this was put on hold setting up these labs due to COVID and budget constraints. So I have 5 4x8 optical tables, nice tables that were donated by a company to put in 5 of these labs. So, but the argon's going to move to this room and to make room for this laser. We have all of our solid states in one lab. We're going to break that up into 2 labs. Our fiber optics lab is going to, we're moving our fiber lasers to the fiber optics lab because it's a pretty large lab, and we can have our fiber lasers and fiber optics in the same lab. Where our engraving laser is in the solid state lab 2, and we're moving it up here. We've been given a new lab that was already a lab, but it was being used for something else, when I came to the school, and so it's always been used for something else, but they've given it back to me. And then we're starting up a applications and research lab where students can go in and like have the OCT in there, the Raman spectrometer, things of that nature, a chopper in there, things that students can leave set up all the time. So this is where the students, my first year students who have really never used these labs yet, they won't until the fall. They're going to be spaced in these labs. I'm going to walk you around with my phone and show you these and introduce you to the students. And with pause at each time, if you want to ask questions or speak to them, feel free to do that. So we're fixing to move to the labs. I'm going to quit sharing this screen. And so you're headed to the labs.
Yeah.
Okay. Let me stop sharing. What?
Stop presenting. Hit that little.
I do. There you go. Thank you. Okay, MJ, I see you have your hand up. I couldn't see it while I was going through all that presentation.
It was about the slides, so you took care of it.
Okay, thank you. Beamer, you had a question?
Yeah, so I couldn't catch the slide, but so you guys have been back in face-to-face classes then for most of the time, this semester and the previous semester?
Okay. In March of last year, they shut us down completely, and we had to go virtual. We couldn't come to the building, and so we finished up all our classes virtually. John and I did. Then during the summer, they made the. I don't teach during summer, but the students take electronics and physics, and physics already distant, but that electronics they had to go virtual. And in the fall, I talked them into allowing John and I to do face-to-face with all our lasers and all our electronics. Because I just didn't see how I could do it otherwise. And of course, we had to promise, we had to sign in, and everybody wear a mask. Of course, and we've been doing that. And the students have been very respectful. It's worked out well. We haven't had any COVID cases that I know. John, did we?
We haven't had any outbreaks here.
Yeah.
So if we had, like one reported, they stayed out, but we didn't have any outbreaks that trace back to here.
And we're real, and John and I pushed the students real hard, and they came in extra days, and we finished up. And then when the COVID rate increased, they actually closed the campus down 1 week early or 2 weeks early. Couple weeks early, and fortunately the students had finished all their labs. I kept telling them, this might happen, and they worked real hard, and they came in the day a week that we have off on Fridays, and they stayed late, and they really pushed through those labs, and so we were fortunate when they shut the thing down that students had finished. And so when we started up in the spring, they wanted us to do as much virtual as possible. So what we did the lecture virtual and the labs face-to-face. That's the agreement we eventually came to.
Now, we're back now with almost everything back on campus. So I have one day a week that I teach 1 hour slots virtual. Everything else we're here.
Yeah, I have 1 day a week I teach 1 hour virtual. How about you, Beamer?
Well, we were a little bit more lenient. What they did was they brought in temperature stations for each building, And so we have to wear these little bands for a different color each day. And my classes were small, and so like 6 students, and Austin's classes were a little bit bigger. But we've been, ever since the summer, during the last summer, what we did was came in 1 day a week, the whole day, and did our electronics lab. And then during the winter, we were back to normal, except we had masks, and we had 1 student per bench, and the 6-foot separation, and then the temperature checks. And what they're doing is the instructors have to get tested every 2 weeks, and so we're still doing that. So from the fall to now, we're pretty much face to face, but we have the mask, and we get our temperatures checked, and basically we get tested every 2 weeks. And so far, we haven't had any clusters or anything. 1 or 2 students in some of the other departments have gotten it, but none of my electronics students have gotten anything. So we're almost normal, and I've had probably half my students have got vaccinated. The other half say, hell no, they're not getting vaccinated. It's a plot and blah, 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 so, so probably the same thing there too. But we've been pretty lucky compared to some of the other departments.
Yeah. Well, we've had a few people to join. Mary, would you like to just introduce yourself? Mary Parker. How about, okay, Mary, go ahead. Is your mic muted? And, okay, how about, go ahead, Mary.
I just wanted to say thank you.
Okay.
And all of the staff there in the laser photonic program for asking the counselor to be with you. Can you hear me?
Yeah, I can hear it. So Mary's our
can you hear me?
Yeah.
Okay.
Yes, Mary is our interface to industry career placement.
Okay, and I just want to.
You're breaking up. Your signal's better now. And Scott Hamlin. Would you like to introduce yourself?
Trying to get control over my mouse. Hi, I'm Scott Hamlin from Megawatt Lasers. I have a couple of our engineers with me. Jason Epinet, I think you know Gary. And this is Chris Hardy.
Hi Gary, I'm Chris.
So Chris is our electrical guru.
Started 1 year ago, just last May.
Just
last March.
Over a year ago. So.
Okay. Well, welcome.
Yeah, thanks.
Thank you.
Let's see. I think that's about okay. So I'm going to go switch to my phone here and try to get to the various rooms. Okay. So if I mute this.
Gary, are you hearing me?
There we go. Mic's on.
On now?
Yep.
Okay. All right, so we're going to start with Mr. Ryan Smith. He's in the laser and photonics lab, our teaching class.
Hello, my name is Ryan Smith, and I'm a student at the lasers program, and I'm also doing dual majoring for geography at UNC Pembroke. Right here, right now, I'm working on a project of measuring the laser absorption. I can see the lasers. And I pretty much hope to finish this degree out and find a nice job.
Thank you, Ryan. Appreciate it. Okay, so now we'll go to another lab. Okay, so we're going to the electronics. Is that okay? Okay.
Don't be afraid to make some talking to. Yeah, I'll throw in the comments.
Okay, so Nicholas is going to talk through this with Mr. Levere.
Hey, I'm Nicholas Van Veer. I'm one of the first year students in the laser program. We've got set up here, which he's getting logged back in. We've got the LabVIEW program. And we've got a program that's set up to run our machines with a power source and a multimeter. And we got it running through LED for this right here. We're going to start it at 0 volts. We're going to increase that 100 millivolts every cycle. We're going to go through the cycle 61 times to get it to 6 volts. Once it's completed the 61 cycles, it'll go through and actually create a graph that we'll see up here where we can figure out the cut-on point of the diode, and we can also see kind of the ranges of the current versus the voltage.
This is for a blue LED.
And then, you want a quick run? Okay. Here we go. So you can see it automatically turns on the power supply. And every time cycle, every click, it's going through and it's up in that voltage. And then it's taking a voltage reading that's going through the diode and also a current reading that is reporting through. And once it's completed with the cycles, it'll pop up onto that graph.
So LabVIEW is the opportunity for programming that we have in this program. Programming for technicians is called. So we learn programming and we learn the lab environment at the same time. And that gives them an opportunity to actually do something where we can go in and create test benches and that. And also, a lot of the programs are just programs that we're not necessarily driving instruments or anything, but just learning basic programming concepts.
So we're at about 3.5 volts right now. And our LED, yep, it's starting to light up blue. I don't know if you can get the LED or not.
I'm not sure it can. Can everyone see the LED?
Yes, we can.
Yes.
There we go, and it should be rounding up right now. We're at 5.96 volts.
And there's our curve trace.
All right. Any questions of anyone? Jay, you have your hand up.
I lost audio again, but I got it back.
Okay. All right. Let's go to another lab. John, come on, let's go.
All right.
Okay. So this will be our new engraving lab with the new laser, and this is Mr. Logan.
Hi, my name is Logan Martin. I'm a federal work study student and also a student in the lasers program right now. This is our future engraving lab. As you can see, it's a pretty big mess right now. But we plan on getting a new laser, which we're super excited for because it's just been approved, along with moving our current engraving setup in this room. I don't know if Mr. Beasley showed you already, but we have the layout set up. So once we get that laser, we're going to go ahead and move everything out and move some new stuff in, get it all set up, and then we're going to have a engraving lab ready to go for all new classmates and next year's students.
Does anyone have any questions of Logan? All right. We'll move on. Thank you, Logan. Appreciate it. And this is the argon krypton that's going to be eventually the new 4,000 watt CO2 laser lab.
Hello. I'd like to introduce my friend Jenna. This is Jenna Carlson, and my name is Kristen Spears, and we are both first-year students in the laser program here at CCCC. And as Mr. Beasley just said, we are in the argon krypton lab. And as first-year students, we are very excited to be able to use this next year and operate all the different lasers and learn everything so that we can be a workplace.
Thank you. And we'll have helium cadmium in here that students do some work on. So, any questions? Okay, we'll move to the next lab.
Yep.
This is the fiber laser lab right now, and it'll eventually be the argon laser lab. Mr. Vicente?
Hey, I'm Vicente Camaros. I'm a first year here at the CCCC. I'm also part of the LEC joint, like the high school and college joint thing. Although I don't know how to use this and utilize it, I am very excited to use it because just looking at this, what makes you get excited? Like if you're seeing this for the first time. So that's pretty much all I have to say for it.
All right. Does anyone have any questions of Vicente? But he's like he said, he's part of the Lee Early College, so he'll graduate in 5 years with his high school diploma and laser degree. So, and he's outstanding. So all these students are outstanding. Thank you, Vicente.
What type of lasers do you have in there?
Mike Sullivan, are you still with me?
Yeah, I'm still here.
Mike, I'm sure you remember Vince.
Yes.
That you hired. Vicente is almost a spitting image of him.
Oh.
I've never seen one that compared so close to Vince in all my life. And between me and you know what I mean by that.
Oh yeah.
He's that quiet and he's that smart.
Perfect.
Okay, so now we're in the solid state. Who's doing solid state one? Logan. Okay. So and I want to since well, go ahead first, Logan, before I jump to that.
All right, so this is the solid state lab. We haven't done any labs in here yet due to me being a first year student along with everyone else. We're super excited. It looks really cool. It looks like there's going to be a lot of alignment labs in here, just mainly precision. And we got some new measurement devices that we don't know the names of. Super excited to learn all that.
But one thing that we have 1, 2, 3, 4 lasers in here, and so that's why we're going to divide this out into 2 solid state labs. But I wanted to show you what Megawatt donated to us because students really love doing this lab, setting this up and aligning it. And in fact, last week or week before last week, we swapped the crystal out in the head, and of course went through a realignment of it. And students, like I say, I mean, they learned so much from this setup. So thanks, Scott, for helping us. And this is the electronics control unit for it. So okay, so now we'll move to the current laser engraving lab that's eventually be the second solid state lab.
Okay. Hi, I'm Joshua Rosaya. This is the laser engraver. And, me and Logan created this Ryan Reynolds portrait, and it's amazing. I am currently dual majoring in welding and laser and photonics. I'm also a veteran. Thank you.
Thank you. Thank you. Matthew?
Hello, I'm Matthew Irwin, second year student. Also do work study with the laser engraver.
Okay, so this is our current laser engraver, and the new one we're getting is, I think it's 60 watt, and this is like 35 watts. The other one's a freestanding larger one, like the old one that we used to have a long time ago. So, any questions? Okay, so now I'll move to the current fiber optic storage room, and Nicholas was gonna just mention that you're covering this lab.
Yep. So this is the fiber lab. We haven't had, as first year students, we haven't had too much experience in here. We'll definitely get to dive our hands into playing in this lab next year. As Mr. Beasley mentioned earlier, we've got some stations set up where we can kind of get some work done and leave it set up and play with it. So we're definitely excited to explore some more in here.
And when we eventually, all this is being used as storage for a neodymium laser, high energy pulse laser, and it's in that crate. The head is, and this is the control system for it. And then all these coolers go with the 4,000 watt laser system. That's the table that'll sit on the in another building. The laser itself is. So hopefully when COVID's over and funding starts back, we'll get to move some of this stuff. And then in this lab, Christine was going to help me in here again.
This is our storage lab. Right now, currently, we're moving all lasers around. Our labs are going to look
Can you hear me? Can you hear me now?
Yes, sir.
Okay. Sorry, for some reason it goes off on my phone, and I think when I received the phone call. When did you lose? What lab were we in when you lost audio?
I think it was fiber.
Yeah, that's one.
The last one?
You were talking about the CO2 laser that was in there, Gary, and we saw the cutting edge laser in there, but you didn't talk about that.
Okay. Well, John, you want to take this back and show them the last labs, or you want
Which, the fiber lab?
the applications lab.
Oh, okay.
Yeah, and fiber lab. Thanks, Matthew. We'll see you, buddy. So while we're waiting for John to go back to the labs, he's going to try to show some stuff to us. Does anyone have any questions or anything? Comments? All right, Beamer.
Hey, Gary, yeah, I noticed that was pretty good. I see you were automating one of your setups there. I guess you were just measuring the current going into LED or something. Are you starting to use that same software to automate some of your other experiments and setups, or is that something that you can do? Or
well, we haven't done it yet.
You're talking about
John?
LabVIEW. We haven't done anything with LabVIEW as far as these labs. That's certainly something that we can look at down the road. We're also talking about adding blanking on the name now. We're adding some into our programming class, Python 3, an introduction to that. But to get to something where we would look at automating our laser stuff, that's a little bit longer term project.
Oh, okay. Yeah, that LabVIEW is pretty good. We use that at just about every place I've worked at. I prefer C, but it's pretty good. And Python is really, really big time now. And we've been playing around with the Raspberry Pis. And I don't know if you guys have played with that, Gary or not, but those are some pretty powerful little things for controlling stuff. And Python's already there, C's already on it, and but I'm not really sure what you could automate, there. But I think the LabVIEW is probably a good step. Are you new to LabVIEW, or I don't remember seeing you doing it before. Is this a new thing?
No, LabVIEW's been around for
No, I mean for you. Is it new for you guys, or?
No, we've been using it here for more than. I've been teaching the programming course for 7 years, and it was in somewhat before that. I'm not sure if it was 2 or 3 years before that.
That's good.
Started. So we're pretty comfortable with LabVIEW as a programming environment, and so right now we're doing the instrument interface and data acquisition interface stuff, basically rather simply to introduce it. But we do have students that have left here and gone on to jobs where they actually use it in an automated test environment.
Okay, good.
Okay. Anything else we wanted to see in here, Gary?
Is the camera on, John?
let me see. Hold on. Can you see it?
Yeah. Okay. So I guess you probably missed this lab. This is our applications lab. That's the OCT. We don't have any of this set up right now. When the students did a lab in the OCT, the second year students a few weeks ago, we brought everything into this lab. But eventually, our goal is to have everything set up in that application lab. And right now, we have a lot of storage stuff that where a company just gave us a lot of equipment, and we're waiting till we lay out the labs, and so we can move some of it around. And a company went out of business, and they just gave a whole bunch of stuff, including those two large lasers, at large solid state laser and the large CO2.
So yeah, we've recently also acquired back a couple of room spaces that we have not had over several years. So we're kind of, part of it's just rearranging spaces.
Yeah, that's a chopper lab for showing Q switching and things like that. So that's the purpose of that lab, is so students won't have to set things up in the classroom and tear it down, set it up and tear it down. It'll just be on all the time, or usable all the time.
Yeah, so this will have a number of stations with essentially a lot of equipment and applications related bench setups.
Is
anything else down here, Gary?
Yeah, that's good. Any other labs we missed that when the audio went out?
Did we get the fiber lab covered, or did the audio miss on that?
Did you hear the audio in this particular lab?
No, we missed that one, Gary.
Okay, John, scan that around. So
okay.
You can see the solid state. Now he's just showed fiber optics, but at one time that whole lab was just fiber optics, but now we're storing that laser and the neodymium YAG laser. It was specially built, is in that case. And then the control unit for it standing up, and there's a cooler in there for it. And then the other coolers is one's for CO2 and one's for the meter for measuring the meter head. I mean, cooling the meter head.
Okay.
And that's
this one. Yeah, this is for the 4 kW CO2 laser, and that's the cooling unit for that one?
Well, there's two I think that's the cooling unit for the head itself, and then there's another cooler that's down there too. There's three coolers in there. One for the
unit here.
Yeah.
Okay. Yeah. So what's the power level on the neodymium?
Oh, I can't remember. Yeah, that's been a year and a half. Okay.
So we got two big lasers basically waiting to be installed and operational. Okay. The 4 kW CO2 laser, the actual laser itself, is in another building right now, and we need some work by the maintenance people to actually get it in the building. Anything else?
That's it, John. Thank you. Anyone have any questions?
Well, in a galaxy far away, long time ago, I had a 100-watt CO2 laser. And I can tell you it was pretty easy to set fire to stuff with it. So 4 kilowatts, so you can have a very small reflection to do a lot of heating up of stuff. So I hope that you guys are being appropriately careful with it.
Yeah, well, yeah, I talked to you about this when we first received it. I think I'm going to somehow try to limit it as much as I can, and I think students would get excited with a lot less uh, energy than that, a lot less power. So it scares me too, MJ.
Yeah, just be careful. That's all.
Yeah.
The good news
Any other
is
question?
clear stuff. Even, I'm sorry. Go ahead.
No, I'm sorry, I interrupted you. Go ahead, John. All right, go ahead. Okay, MJ?
I'm just saying the good news is CO2 is anything is a good protector. Plexiglass windows, glass windows, you know, it makes sure the beam is contained and you know where it ends all the time.
That's a good point.
Gary, I was wondering, what other application spaces are you trying to look at? One of the things that came to mind was there's a lot of activity in LiDAR and using lasers and LEDs for imaging and things like that. Have you thought about, because you can get a little LiDAR card or board now for about $200 or maybe even less.
Oh, that's a real good idea. Yeah, I like that idea. Anyone else have any comments, suggestions?
One of the things that we're looking at on the electronic side of things over the next couple of years is, realizing we had a shutdown for a virus, and every year there are at least limited times when we have shutdowns for weather-related events or such, is not interrupting lab capabilities and hands-on with real devices and such. Well, the good thing out there are little packages now, modules that provide for hard labs. Digital has one, analog discovery and digital discovery series for, in the $300-400 range. You can buy instruments that will give you basically a whole bench worth of instruments and, breadboard capability and that, so you can actually do hard labs with instruments at home. And we have a limited number of those right now that we've used somewhat, and we're, as budget allows, we're going to try to expand that out. And we've actually had a couple, 3 students that have gotten scholarship/grant funds and have actually bought those kind of kits. So we'd like to make our laboratory environment on the electronic side as portable as possible, so people can, don't have to come in. They can, be absent or be out for weather or whatever, and still get real hands-on lab work done. So that's kind of a focus area, and that for analog, for digital signal processing, for anything like that.
I think that's a good point. This is John Muth again. At NC State, when all this was going on, for one of the photonics labs, we took some Raspberry Pis and cameras and sets of lenses and things like that to try to give students something that they could do, at home, and have kits that they could kind of check out, and that kind of thing. I'm not sure how that all really worked or turned out in the final, how much they liked it. I didn't get the feedback on that, but at least it was something that was they were able to do. we didn't. It was mainly imaging oriented and that kind of stuff rather than being more lasers. But that's not too hard to do, and it can get kind of expensive if you're not careful, but then there's some things you can try to do. The new Raspberry Pi cameras are actually really very cheap and actually pretty good.
Yeah. The big challenge with doing stuff that's portable at home is making it well dressed so that somebody can pick it up and get down the road with it. Because when you're in a classroom environment, it's like hey instructor, come over here and help me and answer questions. You can do a limited amount of that with remote meetings, but you can't be real hands-on with it. So you got to have a well-designed thing that's where the experiment is reliable and straightforward and well documented. So that's a challenge for the instructor to put that together.
Any other comments, suggestions?
I think we're all looking forward to some new normal coming very fast, especially for labs.
Yes. Have you been face-to-face with your labs down there at UCF, MJ?
We've been challenged like everybody else. We were shut down last March, and I mean a hard shutdown. And so what we've been doing is sparse labs that keeping distances, so not every student gets to be in person at every lab. We rotate them in and out, whose turn it is to be in the lab and whose turn it is to watch via Zoom or something what's going on. And people are making it work, and nobody's real happy with it, but nobody's been sick. We haven't had any outbreaks. That's a good thing. And everybody's getting vaccinated, so that's a good thing. We're hoping to be back to regular stuff in the fall.
Yeah. Have you started back at NC State, John?
We've been in kind of a mixed mode for quite a while. I ended up doing kind of a hybrid thing, but it ended up being mostly remote. But then I had the students wanted interaction so much, they started coming in on the weekend to be outside to try to do some stuff outside with one course. We just opened up things a little bit more, but it's we're still being relatively cautious. We had a variety of outbreaks and things like that, and I get tested once a week. Almost all the faculty are vaccinated. I haven't heard a lot of resistance from the students, but I'm probably not talking to the ones that are, more hesitant. But I think almost all the faculty, kind of said, "Oh, I'll go ahead and do it."
Yeah, I think same here. I think all the faculty that I know of, John and I have had ours.
Yep.
And in fact, I got mine back, I don't know, January, February. So.
Yeah.
Well, I'm looking forward to seeing everyone at the next meeting. Hopefully in the fall, I'll be able to have the regular meeting and have everyone here. And so some of the same students that you saw today, hopefully will be participating in it because there'll be second-year students ready to go out and conquer the world. So this is a real good crop of students. That's why I wanted them to participate, because that they stay late. I mean, they just work real hard on labs. I see them in your labs too, John, when I walk by late. And
they're also spending a fair amount of time talking to the second-year students who are now in the process of already having a job or interviewing, getting a job, waiting on an offer and that. So they're very attentive to, what's coming down the road for them in terms of their career development opportunities.
I'm just so impressed with how the work ethic of them and how they help each other. They just seem like they're just so concerned about everybody succeeding. And you know how, of course, I love you to teach, you know how every class is sort of similar. Well, that's what this class is just, you know, real good, solid students that are like sponges. Top-notch group.
This is Ken. How is the job market looking for the second-year student?
It's real good for, and you know, two of the students landed locally. One of them went in field service in February. He started working in February, thanks to Scott Hamlin starting having me have the last semester by distance, and he, within a week of interviewing, he had a job. But that was his intent. He's a retired military. He was already working in maintenance at Caterpillar, and you know, his intent was to work in field service, and he's doing a great job. The man that hired him couldn't participate in the meeting today, but he said he's doing outstanding, and you know, he's trying to get more to go. He has he said he's the highest hiring rate he's ever seen since he's been at the company. And in fact, he said he's interviewing a previous student of mine that graduated 2 or 3 years ago. He said he was interviewing him this week. And so I showed you that list of companies that have reached out from everywhere from field service, California. Scott Hamlin had an opening. You know, local companies. So the students that are left are just real picky about where they want to live, what job they want, and they're interviewing. So, yeah.
I think the job market right now is really strong. We're having a hard time finding candidates, actually. So, you know, if you don't mind me making a plug here, MJ, we're looking for bachelors. John, maybe you might have somebody at NC State also.
Y'all probably heard too that Apple is coming into the Triangle and you know, putting in a facility that's geared towards software and AI primarily, and there's already a fair amount of that end of the spectrum in here, and I think that's going to take a lot of engineers and technicians that have the appropriate skills. So I think this area is going to crank.
Okay, so we're open for any other comments or suggestions.
Looks great to me, Gary.
Thanks, John.
John, we're very curious. What are you working on in the background there?
This is a Rube Goldberg machine. It's got a Helmholtz coil, and we're going to put some semiconductors through the magnetic field and stuff. But I am using a little laser cutter to cut a bunch of acrylic and stuff. That's what I've been kind of messing around with here. So it's good training for those guys to figure out what the kerf is and get all the pieces to fit together and that kind of stuff.
Yeah. He should have showed you, but Logan Martin cut out these pieces that fit together and make a cube, and just a perfect fit with that laser cutter, of course, and of course no glue or anything. He's making all kinds. He made a rocket thing. He said.
We made a rocket out of cardboard, sandwiched together. The cube was basically doing dovetail joinery, three-dimensional dovetail joinery. So that was kind of interesting. One of the other things we want to see over the next, over the coming year is, part of this program has been our field trips, our opportunities for the students to get out and see the real world. And we're really hoping to get back into that. So hopefully next spring we'll be back in tour mode. I know we want to get back to NC State to the manufacturing lab.
That semiconductor processing tour just fits right in. In fact, one student just landed a job with Hexatech semiconductor processing. I'm sure you're familiar with them, John.
Yeah, that's a material science professor's spin out. So I talked to them quite a bit. Or not recently, but a few years ago I was talking to them. They seem to be doing fine. You're asking about the job market. I think I'm also seeing, the students here at the college level, having reasonable interviews, reasonable success. It seems like there's a lot of stuff happening and a lot of appetite for good technical skills. And anytime you guys can make it up, I'm happy to give you a tour of the clean room or of, other stuff. There's a lot of interest in manufacturing just in general. I've been sitting in some workshops with the Department of Energy again, and a lot of that's more focused on the semiconductor type of thing. But it seems like, this current administration's got a lot of appetite for both community colleges and for manufacturing. I'm not so much sure about the university research environment. I think they might get there, but I think, there's a need for technicians at all levels, and you guys, I think, are doing a good job preparing the people for a nice area.
When we talk about semiconductor devices in the spring course, I throw in a fair amount of the underlying technology, silicon carbide, gallium nitride, things like gallium arsenide, things like that. Not in any detail, but just to say, for these kinds of applications, here's what technology looks like. So.
Yeah, I think that's really helpful. And, with this electrification of vehicles, you've got all that kind of stuff, with the powertrain and the battery and all that. But you're also, if you think about things like your tail lights are all LEDs now. You've got laser head beams with BMW and other things. There's more of that. And then you're starting to have more and more AI and 5G and connecting to cars. And my personal opinion is some of that's going to end up being with like lights and LEDs and signals that way in addition, or, inexpensive LiDARs and stuff like that. So I think photonics will remain strong. It's kind of a niche thing, but it's an important niche thing.
Yeah, when we went, we did a tour down to UCF a couple of years ago for the, I think it was the Optical Society Conference. We took our first-year students down there, and I remember they were talking a lot about LiDAR and a lot about AI for vehicle automation.
And more sensing too. A lot of it's camera based, but I think that there's just a lot going on and all that. And some of those you're using the LiDARs for illumination and depth, but also spectral sensing. So they can get pretty complicated these days. But I'm pretty sure for like $100, $200, you can almost get a little. I know you can get a LiDAR card that you'd have to kind of fool around with to get an image out, but or you could at least do that. But I think even for just a couple $100 now, you can get some little image demonstrations of little LiDARs and stuff. And students would probably buy into that, would be my guess. It's something, thing. And they're eye safe and that kind of stuff. So.
Yeah. John, you might be interested to, Chris, who's online, is partnering with Power Americas, and he's writing a module. Chris, would you like to speak to that a little bit?
Yes, we're writing a module for wide bandgap semiconductor technology for technicians. So we're introducing, the device structure and the difference between, BJTs and traditional silicon MOSFETs, and how these different devices, how these new devices are different, and advantages and disadvantages, but specifically how to test them, how a technician would test a device, if it's good or bad, outside of a circuit, and how to test it in a circuit. And some of these devices are really, you have to be careful, because by just introducing your test instruments while then the circuit is active, you can create parasitics and oscillations, and then create more damage than you already had in a system that you are testing. So it's an interesting module, and like I said, we are writing this for technicians. We are almost finished, and we'll be sending it out for reviews. We'll be inviting reviewers to take a look at it and give us their feedback.
I'd like to take a look at it.
Sure. I will add you on the list of reviewers, or anyone who is interested, please let me know, and we'll be glad to send you a copy, and then you send us your opinion on that.
Yeah, I'd be happy to look at that as well.
Sure.
Okay. Any other discussion? This has really been great, everyone. It's beginning to feel like old times. I can't wait till next fall.
See you next time then, in person.
Okay. All right.
All right.
Thank you.
Thank you. Thank you.
Thank you all.
Bye bye.
Bye, Gary. Have a good one.
Bye.
Have a good one.
Bye.
Bye.
Thanks, Gary. Bye-bye.
Bye.
To do experiment with, we can figure out how to drive it with LabVIEW or whatever. I mean, we got open license on that. We can put it on any computer in the school.
Yeah.
So. And that would give, for the first years that take the programming course, to see the kind of applications it drives, that would be, I think, pretty informative for them.
Yeah. So how do you get this off, John? Do I have to say block? I'm trying to figure out how to.
I think if you just click off, it'll go away.
I don't either. It's either block or not block.
Well, you can hit allow and then do stop sharing. What is that little pop down there? What does that do?
You can't hit allow. It says always block.
Huh.
I've never had that pop up and stay like that.
No. You want to stop recording.
Yeah, that's true.